we can discover. So we're doing a character class methods. A string is like a list or an array of characters, right? So you can go 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can do, and we did this someplace, we're going to do our scanner input, right? We're going to put it into a character, which means one character of a string, and a string is multiple characters. We enter a single character. Input really doesn't know the difference between a string and a character. We're going to get the character at, notice what's that? What's the 0 there for?
Index.
Right, so it's the index of the first item coming in from input, which is coming in as a string, right? Everything coming in as a string. We just want the first character of that string. So it says next, whatever comes in next, we want the first character of whatever comes in next. We use this someplace.
Last week.
Yeah, we did. Okay. So now we have our character. Now is, here we go. The character class has different methods that can distinguish various things about a character. My hand on the escape key to get rid of that. And I went too far. So we have a character class, which is different than this. This is a primitive variable because there's no new in it. If there's a new in it, it's an object created from a class. This is primitive. So that's how in Java you can tell the difference. When we do a int, we just type in int Fred. That's a primitive variable. Primitive mean we directly store that right on the stack. It has no methods and it's just a variable to store things. That's it. Primitive means it has no brains. This is an object, so it has different methods and things that it can do. So one of the methods that scanner has is it can get the next item coming in from the keyboard. And that's a method because it's connected up right to the object. Make sense?
Yeah.
Now next also has a method called character at. So whatever is coming in next, it'll get that first character. Now, there is also a character class which adds on methods. So the character variable is a primitive variable, but we have a character class that allows us to do things with it. So we can say, oh, is that character a letter? Which that's a letter method. Now this is a class method. Notice we don't have an instance of a character. We didn't make a character object. I wish I could figure out how to get rid of that. We don't have a character object that we've created, right? We don't need one. We're using the method directly from the class. Most of the time, we want an object because we're storing things in it and we're manipulating it. Here, we're just manipulating a character. We don't need an object to manipulate it. We don't have to turn the char character into a object. We can use the class methods to manipulate it and do things with it. Same thing here. Character is digit. Well, it's either true or false. It's either a digit or it isn't. It's either a letter or it isn't. In this case, I added this in just to demonstrate a Boolean that you can make a test and store it as a Boolean result and then say, is that result true? Sometimes you want to do that because you want to have a flag variable. Flag variable meaning, yes, we're here, no, we're there. It's like when we were doing the MBOT. Remember how we kept track of which we were in the remote control or we were in the, it's also called state machine. We were in the remote control or we were in the line following or we were in the, whatever the other one, obstacle avoidance. So it's also called a state. This only has two states, a state machine. It either is or it isn't, but you can keep track of things. So then the behavior of the machine changes based on its state, and the state will change based on the value of this variable. So it either is a digit or it isn't. Ooh, did another one. Is it a letter or a digit? Look at all those things. We can do all kinds of things with characters, can't we? Is it uppercase? Is it lowercase? Oh, we can say, is it uppercase? But look at there. We can convert it to lowercase. So these are all class methods that allow us to do things without having to go through manually and looping and doing all kinds of testing. This method does this for us. It takes that character, turns it to lowercase. A method written in the programming language helps us not have to write it ourselves. In C++, there's not a lot of help. In C, there's not a lot of help. You have to do everything yourself. You have to dig the hole, plant the tree, where with Java, it says, here's the tree, go and water it. Make sense? So we're dealing with characters because characters are part of strings, and this is a good time to learn about the character class. When we're doing manipulation with strings, sometimes we have to break it apart into characters to work with. Sometimes. Depends on what we're doing. A string is a class. When we create a new string, we don't have to explicitly do new. This is like a shortcut constructor to create a string object. You can do it where you say equals new string Jon Snow. But this is a shortcut way to do it. Java handles that in the background. So now this is an object, 3 of them. I don't know why Jon Snow is in there twice. Anyway, and I don't know what Jon Snow has to do with Johnny Depp either, but so we can iterate through the string one character at a time. So strings, because they're a class, have methods. Length is one of the methods. So arrays have a length method, right? So is a string like an array? Absolutely. It's an array of characters, as Mike said earlier. An array of characters. So I can go through one at a time and print each character. It's indexed. So I start at 0. I get the first character, JOHN space snow. Space is a character. Anything you type on the keyboard and many things you don't type on the keyboard are all characters. So this will go through one at a time and print each of them separately. So far, so good. And I put a space between it just to show that, yes, that indeed is what's happening. Can we do, before I do this, I should say, in Python, we'd say if Fred equals to a certain string. And we could do that, right? We can compare a string to a variable containing a string directly. Well, everything in Python is an object. And if you actually compare the objects themselves, what are you actually comparing? You're comparing the address. We need some drawing. I wish my tablet worked. So here is my primitive variable. I can store 14 in here. That's it. The primitive variable and the address space are the same thing. The address space of the primitive variable is one thing. When I create an object, what's in here is actually an address that points to where the information is actually stored. So this would have the, whatever word I had up here. So Python does this. In Java, it does this. But in Java, it doesn't have all the help that Python gives us. When we compare two objects, which a string is an object, object A, object B, what are we actually comparing? This is the information, remember. What are we comparing when we compare these two? We're comparing the addresses, which is never going to work.
They're always different.
They're always going to be different. However, in Python, it does that for you in the background. It says, I know you're not trying to compare objects. I'm going to compare the contents of those objects. So Python handles that in the background.
Using overloading of operators.
Yep. It handles that for you. So Python is great, except it does a lot of things for you. And then you don't always if you only know Python, you don't know the inner depths of computer science. And this is the inner depths. Oh, I forgot to erase my thing. How do I erase it here? There we go. Clear all my ugly drawings. All right. So we have to have a method. Well, this is actually what is happening in the background in Python. It has a dot equals method running. It's probably a dunder method or something that compares the values together. Because with an object, what's stored in the object memory is just the memory address of where the information is actually stored. So the only thing stored in the stack is the address of where it's stored somewhere else, which is probably the heap. I don't know that much of it, but it's stored somewhere else. So we're comparing the value of name with the value of this, and that's what the dot equals method does. And we can also compare. Oh, what's Unicode? Does anyone remember Unicode? What's Unicode?
It's a set of characters, characters.
It's all the characters that we use when we type in and some we don't type in. So you can see, oh, wow, these are some interesting ones. Anyway, say this was an L and you typed it in, the computer doesn't see L. It sees these little hexadecimal numbers. So every character, even if you can't type it in, like emojis and everything else. I thought it would show some emojis. Anyway, all these, yeah, I don't know where they are. Anyway, that emoji, the computer doesn't know it's an emoji. It just knows that it's a hexadecimal number referring to something. So it can be invisible things you can't see, like the enter key is invisible, space bar is invisible. They all have Unicode numbers. And so this is another way of comparing these two together to see if they're actually the same, because it's comparing the Unicode representation. So is this one equal to this one? Yes. Is this one not equal to this one? No. We could switch those methods of comparison around. Let's see what it does. Oh, why does it say less than or equal to? Because in Unicode, it would start out like A might be 1, B might be 2, C might be 3. The numbers associated with the letters can be compared directly. So if the hexadecimal representation of this is a higher value than the hexadecimal representation of this, then this would be greater than this. How about that?
Yeah, I vaguely remember this from a previous term.
And this is getting down into the depth of computer science 1 and working with strings. But understanding Unicodes allows us to do things like putting in funky characters in our programs that we don't know anything about, instead of just copying and pasting. Anyway, we'll move on from there. Just recognizing there is such a thing as Unicode. There are characters outside of the keyboard that you can type if you type in the Unicode. In fact, in Windows, there's a character map. And we're in Arial. So for instance, the number 5, there's the Unicode, 0035. Number 7, 0037. Well, notice 7 is greater than 5, and it's also the same in Unicode. How about A? The number A is 0061. B is 0062. So that means B is greater than A based on Unicode numbers. Now, what if I want to put something like this in something? It's a vulgar fraction. Oh, that's too funny. So you can select it from here and then copy it and paste it into your program, and you'll have a 3/4. How many people have a 3/4 key on their keyboard? Nobody. Nobody. Nope, nope. You can also use this little shortcut. If you hold down your Alt key and type 00BE, left of the Alt key, it'll type it in for you. But I'm never going to remember that.
And you can use keystroke Alt plus 0190. There's in the corner.
Oh, that's the keystroke. Sorry, I was saying the wrong thing. Thank you, Mike.
If you
Alt
do
0190.
Alt and 0190, it will give you 3/4.
Yep. You can copy and paste it, or oh, I don't have a program open. Let's open this one. Alt 0190.
Yeah.
Why doesn't it like it?
Yeah.
because this is not plain text. Plain text is ASCII. Oh, no, it's not, that's not why it's liking it. Let's do it. It's in the wrong, maybe it will like it. Because it is plain text, isn't it? Yeah, okay, let's try that. We're gonna do
plain
it.
text, but it's not inside the variable or something.
Yeah, I don't know if it's in the wrong place. Oh, we don't want that. We want Alt 01, what was it?
90.
90. Yeah, it's not a number.
Yeah, it will work.
It's a
as
character. If
as a
I do it as a
character.
string, I can do it. Yeah, but it's not a number.
Mhm.
Okay, that cleared that up for me. All right, moving on from string methods to, oh, that is actually what the next thing is Unicode. Oh, I forgot that was in there, yeah. I looked through this last weekend and I forgot it all. So in a program, if you want to have a heart, you can put in this little Unicode character. You have to do a slash ahead of it to escape the U, meaning we don't want U to print out. We want the program to recognize that this is a Unicode character. So if we run this, it may or may not work. Let's see if it works now. Yeah. There's a weird thing in Windows. It works just fine. In Linux, but in Windows it doesn't because the terminal is just not as good as Linux's terminal. What can you do? So you have to do this first to turn on the code page, which is dumb. And then when you run it, it looks pretty. No, you have to run it on the same thing. So yeah, I've almost am ready to take that one out because it works so stupid. But you could do it if we did a bunch of stuff, but this does work in Python just fine. Yeah, I was thinking about that this weekend, but I didn't take it out. So I did give how to do it over here. So if we bring up our terminal, and we have to be in the same terminal that we were before, that'll activate this terminal with the code page. Slash. Oh, it didn't work right. It has worked in the past. I don't know why it's not working right today. Maybe you have to be in an actual command line. I'll research that because I know it worked at one point. Because this is what I did to run this. You can initialize a string variable and convert a previous one to uppercase because this is a string, this is a string. So to uppercase is a method and strings are objects. So the object being operated on by that method. So that means if we save this as something or assign it to something else, it's now uppercase, where we were doing character before in C++, right? We were using a character, no. In Java, we're using a character class method. This is a string object method. Because a string is an object. Here's an interesting one. You can slice the string at different characters. And what is this like? This is like the colon operator in Python. We're not going to do much with this. You just should be aware there is a way to get a substring. In later programming classes, you're going to have to be able to slice strings apart and put them back together. We just run out of time to go through every single thing in this class because I'm trying to do more of different languages. Now, string builder, Mike earlier said that strings are immutable.
In Python.
And
In
in Java and everything, they're immutable. But Java thought, oh, I don't like that. I'm going to create a string builder object where I can modify strings. So it's a string, but it's a string builder object. So it's just a different type of string object. And then it can behave just like an array. I mean, strings would behave like an array anyway, except you can only access it. Here, we can insert different characters into it. We can replace things. We can delete things. So we can modify it. We can also make it longer, which for some, oh, there it is. Yep, we can make it longer right there.
Mhm.
So it starts out as Jon Snow. We can append to it So string builder is like a list of
I can see.
characters. Oh, then we have a couple fun assignments. So here we go. We have, going through these tutorials, you'll have learned everything you need to know to be able to do this. This is a really typical program for strings. You take 3 words and create an acronym of it.
Mhm.
So like IDE, you have these strings coming in. How do you get the first characters out of it? Well, that's a good question. How would you get the first characters out of each of these?
Mhm.
Remember, each character of a string is a character. And you can find things in a string. And you can look at each character in a string and you can compare characters directly.
Yeah,
So this is my interpretation of LOL as laugh over lunch.
Yeah.
So this can be done with everything that we've done in here. You'll just have to break things apart and
Mhm.
figure out how to do it. But this is a very common this is a very common string problem. Is to take parts of a string apart and put it back together.
It would be very, very easy in Python, but in Java, it's
Java, it's a little
it's a
different,
little
yeah,
different. I know, I already solved it. I know.
because you have to go between characters and strings. You have to pull things
Yeah,
out
yeah,
of the
yeah,
character.
just figure out where the white space is, where the new
Yep.
word started, and to get that
And with
simple.
Python, you can just do it
Create
with
a
one-
new string, add new beginnings of the word in that and in the uppercase, and that's it.
Exactly. Mike just gave you the pseudocode for the program.
But in Python, you just split it into words and take first